Welcome to the Engineering Hustle. So I finally got around to finish the design for my Cinewhoop. This is actually the first Cinewhoop I built, and of course I will 3D print it to use my 3D printer, and therefore I did the design. And for this design I used FreeCAD, which is an open source software. It takes some time getting used to it, but once you're used to it, it's quite comparable to a commercial software, so it's quite good to use. So we'll walk you quickly through the different design parts and then show you how I built it, and let's see then how it performs outside. The bottom part of the frame holds the 4 motors and the ducts as well on the side. And in the interior there is space for all the electronics. The FPV camera is mounted on 2 plates between the top part and the bottom part of the frame. This is exactly the same as I showed in my previous video, where I go through the process of designing a frame for a 5-inch quad. I will put a link somewhere in the description or up here. For the props, I put 4 ducts on the side to cover the props. Now it's time to put everything into the 3D printer. First I will put the ducts and the action camera mount. Therefore I will use TPU, which is a flexible filament. Then for the top part, bottom part, and the camera mount, for the FPV camera, I will use PETG. The 3D print for the ducts and the run cam mount just finished. I used a bed temperature of 60 degrees and an extruded temperature of 200 degrees. And here comes the next 3D print. It was done with PETG. I used a bed temperature of 70 degrees and an extruded temperature of 230 degrees. For this 3D print of the drone, I used PETG as a filament, and in the beginning I used 3 millimeters thickness. Since it's a small drone, I thought it's strong enough, but as you see it bends a lot and it's nearly not as strong enough. So I printed another one right away. Same design, just 6 millimeters, and it should be stronger. This time I used a proper technique in designing the frame. I used assigned parameters, and so I could easily change the thickness from 4 millimeters to 6 millimeters, and that's it. And that's how I put it into the 3D printer in the end. And now I will put all the parts on the drone and assemble it, and let's see if it's strong enough. After 3D printing everything, I mounted the motors on the frame, then soldered the motors on the ESC. From there, I soldered all the components to the flight controller, closed up the unit and put the top plate on it, and finally I mounted the ducts and the run cam mount. Before going outside, I did a quick check inside. Even though it's very loud and annoying inside, I went outside and continued to check the performance. As you just heard, the sound is very high-pitched and annoying. However, the drone flies really well for a Cinewhoop. Of course, it's not as powerful and good as flying a 5-inch quad, but for Cinewhoop it's really great to fly. Thanks for watching, and please let me know your opinion about this Cinewhoop in the comments.